Welcome to The Explainer. Today, we are diving into a pretty radical approach to healing. Now, imagine using a solution that's as acidic as your own stomach acid to treat a really bad skin infection. I mean, you'd expect some serious trouble, right? Burns, damage, maybe even scarring. Well, this case study shows how that exact method got a perfect result with zero harm to any of the healthy skin. So let's break down how that is even possible. Okay, so this is what we're dealing with. And you can see this is not just a mild case of athlete's foot. Look at that severe buildup of hardened, dead tissue. This is a chronic, deeply embedded fungal infection, one that has basically built a fortress for itself against all the usual treatments for years. And that is the core of the problem, right? The fungus isn't just hanging out on the surface. No, it's hiding deep down, underneath a really thick protective layer of keratin. That's the protein our skin is made of. This layer has turned into a kind of biological bunker, and it's shielding the fungus from any creams or sprays you could possibly throw at it. So, how in the world do you breach that bunker? Well, this case study walks us through a 7-day experiment that uses a very, very unconventional approach. Let's take a look at the protocol. You know, at first glance, the protocol itself looks pretty straightforward. Step 1, you prepare this special solution, this pH 1.5 proton water. Basically, it's water that's been engineered to have a ton of reactive protons, which is what gives it that ultra-low pH. But then, look at the next steps. It's all about exposure. Soaking the foot for a full hour, 3 times a day for 7 straight days. The key here isn't just how potent the solution is, but that relentless, sustained contact you need to finally break through those defenses. So, how does this whole thing actually work? Well, the strategy is really a 2-part attack. The very first step is to systematically dismantle the fungus's defenses. You've got to unlock that bunker. The whole process relies on this key principle called keratolytic action. Now, I know it's a fancy term, but all it really means is using a substance to chemically dissolve and break down that tough outer layer of skin, that keratin shield that's protecting the fungus. In this slide, this just lays out that attack perfectly. It's a 3-phase breach. So first, you've got the bunker, right? That thick keratin shield where the fungus is all safe and hidden away. Then comes the breach. The protons in the water get to work, chemically dissolving that shield, just breaking it apart. And then finally, you get full exposure. The bunker's gone, and the fungus? It's left completely, totally vulnerable. So, with the bunker totally destroyed and the enemy exposed, it's time to deliver the final blow. And this is where the extreme pH of the water really comes into play. And this illustrates the kill mechanism brilliantly. You see, fungi, like most living things, have a little comfort zone. They like a neutral or maybe slightly alkaline pH. This treatment creates the exact opposite, an extremely acidic pH 1.5 environment. This sudden, drastic change creates what's called a fatal pH shock, and it just shreds the fungus's cell membranes and shuts down all its essential functions. It simply cannot survive that. Okay, so the theory sounds really solid, right? You break down the defense, then you eliminate the target. But let's move on to the results and see how this 2-part scientific assault actually played out in the real world. This timeline really puts it all into perspective. The treatment itself, only 7 days, starting back on December 4th. And by the end of that 1 week, all the heavy lifting of dissolving the dead tissue was done. Then the body's own natural healing process just took over. And a little over a month later, by January 10th, the skin had fully regenerated. This slide shows a really crucial part of that healing process. See, after that 7-day treatment dissolved the bonds holding all that dead keratin together, the compromised layers of skin just started to naturally peel away. I know, it looks dramatic, but it's actually the body just efficiently shedding all the dead, infected junk to make way for new, healthy skin underneath. And here it is. This is the ultimate payoff. I mean, the before and after is just staggering. On the left, you've got that chronic, hardened condition in December. And on the right, just over 1 month later, the result is perfectly healthy, completely regenerated skin. This isn't just an improvement, it's a total reset. So this incredible result immediately brings up a huge question, one you're probably thinking right now. A pH of 1.5 is extremely acidic. We're talking stronger than lemon juice, getting close to stomach acid. So how is it even possible to get this kind of result without causing chemical burns or damage or any scarring to the healthy skin? Well, the answer lies in this really revolutionary technology. At its core, something called selective reactivity. This isn't just any old acid. It's engineered with these special proton clusters that basically act like smart bombs. They're programmed to aggressively seek out and destroy only dead organic matter, so the fungus and its keratin shield, while completely ignoring living, healthy cells. They just don't react with them at all. This powerful statement from the source material just sums it up perfectly. Lethal to impurities, safe for biological essence. In other words, it's absolutely deadly to the dead stuff, the fungus, the keratin, but it's completely harmless to the living tissue that you want to protect. So think of it like a key that only fits one very specific type of lock. These proton clusters are designed to only unlock and break down the molecular bonds found in dead matter and fungus. They don't fit the lock on healthy living cells. So what you get is this targeted demolition that clears out all the bad stuff, and it creates this perfectly clean and safe environment for new skin to grow back. So when you put it all together, what we've really seen is something way more sophisticated than just cleaning. This is a targeted biochemical mission. The goal? Dismantle the fortress, eliminate the occupant, and do it all with such surgical precision that the surrounding city, the healthy skin, is left completely untouched. And that, of course, leaves us with a final thought about the future. I mean, if this technology can so effectively and safely dismantle this one type of biological bunker, it opens up a really fascinating question. What other stubborn medical challenges, or even industrial ones, could this unique principle of selective reactivity be used to solve next?